65 million years ago, dinosaurs fled the Earth to avoid an asteroid crash. 65 million years later, one dinosaur returned, only to discover a planet ruled by humans. And what a mess those humans have made. My name is Artius Zeradar. After pledging years studying the absurdity of the human race, I determined to right the wrongs of this inferior species by exposing its flaws. This is the Artius Zeradar Show. All right, welcome back to the Artius Zeradar Show. I am Artius Zeradar. So last time I talked about psychology and mainly how one of the major flaws of psychology is that it is science. Not that I'm saying science is a totally flawed system, but it has flaws. And so I discussed the flaws of science itself. Now I'm proceeding to suggest that, or to argue that, psychology doesn't even measure up to that system, to science. Psychology is even more flawed than science. Let's start with psychological experiments. So, as I've noted, psychological, or at least scientific experiments, don't deal with deductive logic typically. They use the inferior inductive logic. At most, they can prove only the relation between an independent variable and dependent variable. They claim it proves causation, but that violates David Hume's law of causation. Psychological experiments increase the problem even further. So first and foremost, the overwhelming majority of psychological experiments cannot isolate an independent variable and a dependent variable. The only way to properly test the relation between the independent variable and the dependent variable is to keep all of the variables constant. Psychologists can't do this. There are all sorts of variables when dealing with human behavior and human thought. This alone invalidates psychological experimentation. If you were to look at a physics experiment, you can see, like Isaac Newton will test a particular object and isolate its weight compared to its acceleration, and all other variables are kept the same. But this is not the case with psychology. It's like a tornado. It's like a weather system, right? A weather system has so many variables, you simply can't conduct experiments on them and isolate the independent and dependent variable. So psychologists counter that they have many methods that deal with this, and to some degree it's correct. They do have some methods that can handle some of these issues, but the issue for me is that they still fall short at the end of the day. So first one is randomization. So psychologists will conduct experiments on samples of people. They claim that if they select this group randomly, all the variables will cancel each other out. First, I don't know that it works that way. Second, to what degree are the variables canceled? For example, if I pick 50 random days of the stock market, each day of trading is filled with countless variables. Using the principle of randomization, these variables would cancel each other out, right? Now, let's say I purchase $50 million worth of Amazon stock at 9 a.m. on each of those days. That should produce some sort of effect. All the other variables will cancel out. I think not. I don't think that having, 50 random days of the stock market is all of a sudden going to isolate the independent and dependent variable. Those of you who have any experience in the stock market will, I think, attest to that. Let's then, if we assume that's not the case, and maybe I'm wrong. I mean, if you can show me that is the case, that you can predict stocks with enough randomly selected days, okay, I'll listen to it. But I I have a hard time believing that. Let's use that assumption under the deduction of the day. So, under the deduction of the day, we will begin with a principle, our major premise, Q to R. A selection of random samples will isolate the independent variable and dependent variable. That's the assertion put forth by the psychologist. And then we'll apply that to the minor premise. A selection of 100 random people is a selection of random samples. And then to the conclusion, we conclude that a selection of 100 random people will isolate the independent variable and the dependent variable. Now, applying that now to the second scenario, we keep the same major premise, so I'm going to link that to both deductions here. The second minor premise will be a selection of 100 random trading days as a selection of random samples, and then finally the conclusion is a selection of 100 random days will not isolate the independent variable and the dependent variable. So we can see here that there is some sort of logical inconsistency under our double deduction. Essentially, I'm putting forth a counter argument, a counter example, proof by counter example. So even if we assume the principle true, its truth will never reach certainty of a hard science experiment. Unaccounted for variables will always raise questions. So I guess there might be some truth to it. I would need some more demonstration. Let's get to the next part, the next method used by psychologists to handle the inability to isolate independent and dependent variables, the blind experiment. So the blind experiment is supposed to somehow keep the psychologist unbiased. So another method psychologists rely on is something called the blind experiment. In a single blind experiment, the participants are unaware of the experimental conditions. In a double blind experiment, neither the participants nor the researchers interacting with them are aware of the particular experimental conditions. So by making everyone unaware of what's being tested, their biases will not show. So a blind experiment is intended to remove the bias of the researcher. The very existence of this idea, though, proves, I think, that there is something fundamentally wrong with psychology, that a researcher's bias might even come into play, reveals that psychology is not a mathematical practice. We don't concern ourselves with bias when we do long division, or we don't concern ourselves with bias when we perform a quadratic formula. We don't concern ourselves with bias when we test for the influence of gravity. The very notion of an experiment designed to remove bias reveals that psychology is not science, or at least it's not math, right? It's not a very mathematical subject if you're concerned with the person doing the math. Why would we need to remove the researcher's bias unless the researcher is called to make some sort of judgment beyond simple measurement? For that very reason, the researcher is indeed called to make judgments. So yeah, I see a lack of science here. Now let's get to the next part, the next critique, which is, or at least the next defense by psychologists, which is statistical significance. In other words, the probability of randomness. So there is this system that is often abused called, or I should say, I don't know, system, but there's a method that is often abused that we call statistical significance. A psychological researcher doesn't seek a one-to-one correlation between independent variable and dependent variable. So they don't demonstrate that there is necessarily that, when you shift this one shift the dependent variable necessarily follows in a strong correlation. Rather, the psychological researcher often seeks a correlation well below 100%. The psychologist seeks a 95% chance the results are not due to chance. So it's a very different statement than saying that they're strongly correlated. Rather, we're just simply saying that whatever correlation we do see Whatever change we see in the dependent variable, it's not likely due to chance. That's the way the argument goes. So, again, that's not to say there's a correlation between an independent and dependent variable, or at least a strong correlation. It's not to say that your hypothesis is 95% truth. It simply means that the results are probably not random. This is what they call the p-value. And the statistical significant threshold of p is arbitrarily 0.05. Now, this is a fairly persuasive argument, actually. I think the math is kind of convincing, actually, here. That they're saying that we can determine what the results would be if it was purely random, and then these are the actual results. And we can then kind of measure the degree to which the actual results are different from random results. And in my mind, there's some persuasive argument here. So, I have to give kudos to the psychologist to some degree. However, researchers have been known to use this number abusively, which kind of demonstrates that maybe this number doesn't quite work as well as we think it does. For example, a low p-value might demonstrate that the independent variable has some effect on the dependent variable, but it might not be a very large effect. So we see some cause and effect, and the p-value shows that there's something more than random, but the effect is so minimal that it skews the data. Some researchers will purposefully seek p-values of this nature because they want to get it published. This is called p-hacking. So they even have names for these things. It's a known problem that researchers are creating studies that don't really reflect something significant. They're just kind of twisting the numbers. So the American Statistical Association found it so troubling enough that they announced that the p-value is commonly misused and misinterpreted. That's their words. It also asserted that a p-value near 0.05 taken by itself offers only weak evidence against the null hypothesis. So, people in the field are well aware of it, and they're critiquing it. Further, papers with a low p-value are more likely to get published. So I find that a bit problematic too. Shouldn't we be interested in papers demonstrating no statistical significance too? In fact, the papers showing no statistical significance, in my mind, are more important because they are falsifying. That's the central goal of science, is not to prove, but to disprove, to falsify. So the very fact that journals accept the lower p-values demonstrates that researchers are trying to prove, not disprove. And as I noted earlier, when they seek to prove instead of disprove, they are doing so using inductive logic, which is susceptible to the flaw of induction. When you falsify, you're actually much closer to the deductive method, which is, in this, what I'm referring to as proof by counterexample. Speaking of proof by counterexample, let's go into that a little bit. How do psychologists handle counterexamples? So psychologists are disregarding a fundamental rule of logic, particularly proof by counterexample. What is proof by counterexample? So when you assert a claim, but an example exists that is counter to that claim, you have a counterexample. It only takes one singular counterexample to disprove the rule. That's it. And that's a rule of logic. One counterexample, and the principle has been disproved. However, psychologists treat counterexamples as anomalies. Okay. I find that to be more than problematic. That's entirely erroneous. It violates the rule of logic to simply say, oh, well, that particular, because it's outside the realm of everything else, that's what we call an anomaly to the rule. It's not an anomaly, I would say. That's a counterexample. That's a direct violation of logic. your rule has been disproved. Let me present an example. So suppose someone wants to test the following hypothesis. If a football accelerates towards a person's face, the person will catch the football. That's my hypothesis. To test the hypothesis, I throw a football at several randomly selected people. And let's say the results are as follows. Imagine that 99% catch the football, but one person does not. The researcher will usually conclude that the experiment proved the hypothesis true, and the exception was merely an anomaly. However, this violates logic. The person who flinched is a counterexample. Proof by counterexample disproves the rule. So the proper way to handle this situation is to revise the hypothesis. Add qualifiers to the hypothesis. If a football accelerates towards a person's face and X, the qualifier, then the person will catch the football. So if I can, account for the exception by revising my hypothesis, then I am maintaining logical validity. That's the way to properly deal with it, not to declare something an anomaly. If the extra variable does not change the outcome, the researcher should add another variable. If a football accelerates toward a person's face and X and Y, then the person will catch the football. The researcher should continue adding variables until counterexamples are removed. But this isn't how researchers handle experiments. They accept anomalies, and they rely on statistical significance. This is, again, a flaw of psychology. Next, psychologists give the impression that these methods cancel out all the problems inherent in psychological experiment, but I disagree. These methods do not suddenly erase the problem of dynamic variables. In other words, the existence of variables outside the dependent and independent variables. If you cannot isolate the independent and dependent variables, you simply cannot determine with certainty whether the independent variable is the cause of the dependent variable. Studying the brain is like studying a weather system. The variables are too complex to account for. And then there are experiments that use qualitative measures instead of quantitative measures. I'll go into some of those experiments later, but those experiments to me are just appalling. They're not even measuring things on a quantitative method. They're using people to kind of determine what the variables even are. So modern statistics can demonstrate correlative strength through compared to randomness, and as I said earlier, those arguments on statistics are persuasive. I think there's actually some good argument there. However, statistics are still inductive, and the correlative strength in the soft sciences will always fall short of the correlative strength in the hard sciences. So as I said earlier, imagine comparing mass and acceleration. The correlation is nearly 100% when a physicist tries to prove F equals ma. The correlation is just extraordinarily high. That is so different from psychology, right? Correlations from psychology are significantly lower. Now, let's get to the real proof, the deepest flaw of psychology. It's been known now for a long time, many years, and it's just like, okay, we win. Psychology is flawed. I mean, the argument I'm proposing here wins based on this one thing more than anything else. Replication rates. So in science, there's an idea that if you can replicate the experiment, then the experiment is valid. Well, guess what? You cannot replicate psychological experiments. They've proven this. So they've gone through and they've tried to replicate experiments. The replication rates have been thoroughly surveyed over many years. These rates demonstrate whether their results are valid. Current replication rates in psychology are lower than 40%. lower than 40%. Consider just how abysmal that number is. It's less than a coin toss. So you would do better flipping a coin as a determiner of truth than you would investing faith into a psychological experiment. I don't think there's been a method in history that performs that badly. A number as pathetic as 40% should prove to everyone that psychology is wholly unreliable. The entire study should be eradicated. It should be crumpled into a ball and thrown in the trash. All right, so that's how bad psychology is. I mean, there's your demonstration right there, I think. Let's go further. So worse than experiment, we have other studies. They don't just do experiments. They provide studies in the form of correlation, surveys, simple observation. Why on earth would we give psychologists some kind of elevated status? It blows my mind. So we see first that the psychological experiment is vastly inferior to the experiments conducted by hard scientists. But even more troubling is that many psychologists often don't even conduct experiments. They conduct surveys, correlations, and mere case study. Singular examples. Another method is naturalistic observation, where the psychologist simply writes down observations, but naturalistic observation doesn't place a psychologist above any of the rest of us. We all observe. And our conclusions from observation are either speculation or simple induction. Students of psychology are typically told they can use any of these methods. But this isn't science. Yet we see wide swaths of research conducted in this fashion. If a psychologist presents no experiment and no scientific method, then what is the psychologist presenting? Nothing that particularly guarantees truth. Moreover, there is the problem of third variables. Correlation between two variables does not guarantee direct relationship. A third variable can be the cause of both variables. So one classic example is a correlation between ice cream sales and crime. So, you may have heard the phrase, correlation is not causation. Hopefully you know that phrase. This is a great example of it. Third variables prove this. So there happens to be a strong correlation between ice cream sales and crime. One might think that ice cream sales cause criminal activity. Ice cream makes people criminal. But in fact, the two variables are both caused by a third variable, which is temperature. It turns out that when it is warmer outside, more people want to buy ice cream. And simultaneously, more people are willing to commit crime. So warm weather causes crime, and warm weather causes ice cream sales. During the cold winter, few people want to eat ice cream, and few people want to commit crime. The third variable is easily an explanation on all sorts of experiments and correlative studies in psychology. So many times it can come up, and we just ignore it. Interestingly enough, psychologists admit to all the flaws I just put forth today, for the most part. I think every flaw I've asserted today you'll find in a psychological textbook. So let's take a look at a psychological textbook. Here's a page. By admitting to these issues openly, the psychologist appears to demonstrate good critical thinking. However, the psychologist almost uses these admissions of flaws to gain your trust, and then proceeds to publish conclusions based on these fallacious methods. That's what I've noticed. Is they will admit to the flaw, and it's almost as if they're saying, "We're aware of it. See, we're not going to produce things without being aware of these flaws." But then they produce those same things. I'm going to try to do this over the course of the next several podcasts, but show you some of these studies. And just open up one of the journals and take a look for yourself. You'll find they use these flawed methods that we just went over. So the psychologist says, yes, my study has flaws, but since I admitted to them, you can see that I'm honest and I'm a good thinker. not buy into my conclusions wholeheartedly. And I mean, I've seen psychologists assert their views energetically, and they're trying to persuade. I'm sure there's many psychologists that might deny this, that will insist on using rigorous method, but the psychologists that do that are either the minority of psychologists or they're dishonest. So psychological journals, like I said, they're polluted with studies based on things that are not experimentation. Surveys, correlations, case studies. If the human species is so captivated by science, why allow the publication of unscientific studies? Why elevate psychology? I argue we should do the opposite. I think there's a problem with publishing these things in psychological journals. Now, I don't want to take away from exploration of ideas. I think there's some value to these things, actually, believe it or not. But we've elevated the value. And so I would argue that if we're going to have like these inferior studies with surveys and correlations and such, we should place them in some other kind of journal and almost give it a silly name. Like treat them like some kind of tabloid magazine. Because honestly, that's how they deserve to be treated. These studies deserve to be treated like tabloid magazine articles, but we're not doing that. We're not treating them that way. And that's the issue. So the issue is the pedestal. So if premises in psychology are not built on scientific fact, what are they based on? A great number of them, speculation, beliefs, opinions. Opinions are fair. I have no problem with opinions. But we shouldn't elevate opinions from psychologists to a level above the rest of ours. And that's the problem right there. It's just the elevation. We elevate it as if it's fact. All right, well, that will be, I think I'll close up today with that thought, and we will continue next time with a few more critiques. My name is Artius Zeradar. You're watching the Artius Zeradar Show.